In this video, we are going to solve question 1 of exercise 1.2. The question is, express each number as a product of its prime factors. So every number which will be given over here, we need to prime factorize it. Now first number here is 140. So let's find out the prime factorization of 140. Let's divide 140. Since it is an even number, we can divide it with 2. We are going to get 70 as a quotient. Again, 70 is an even number, so we can divide it with 2 and we are going to get 35 as a quotient. Now, if you will try dividing, we won't be able to divide it with 2, right? Because 35 is an odd number. So, we'll try dividing it with 3. On dividing it with 3 also, we are not going to get remainder as 0. So, therefore, we'll try dividing it with 5. Now, 5 sevens are 35, so we can write down 7 as a quotient over here. And now, 7 is a prime factor, so we will be dividing 7 with 7 in order to get 1 as a quotient. So, we will be writing now 140 as a product of its prime factors. So, 140 is equals to, we will write down all the prime factors, 2 into 2 into 5 into 7. Now, this can be further written as 2 raised to 2 into 5 raised to 1 into 7 raised to 1. So, this is the way we have prime factorized 140. It can be written as a product of prime factors as 2 raised to 2 into 5 raised to 1 into 7 raised to 1. Now, let's look at the second subpart. So, the second subpart of this question is, we have to prime factorize 156. Now let's try dividing 156. Since it is an even number, we can divide it with 2 and we are going to get the quotient as 78. Again, 78 is an even number, so we can divide 78 with 2 in order to get 39 as a quotient. Now 39 is an odd number, so we will try dividing 39 now with 3. If you will try dividing 39 with 3, we are going to get 13 as a quotient. Now we came up with a factor here, which is a prime factor, right? 13 is a prime factor. So definitely it will be divisible by only 30. And hence we are going to get 1 as a quotient. Now we will be writing 156 as a product of its prime factors, which would be 156 is equals to 2 into 2 into 3 into 30, which can further be written as, since 2 is occurring twice, we will be writing 2 raised to 2 into 3 is occurring once, so 3 raised to 1, and 13 is also occurring once, so we will be writing 13 raised to 1. So this will be the product of the prime factors of 156. 2 raised to 2 into 3 raised to 1 into 13 raised to 1. Now let's solve the third subpart of question number 1. So let's divide 3825. Since it is an odd number, we can divide it with 3 first of all, because the sum of all the digits of 3825, it will give us a number which is divisible by 3. So we can divide this number with 3. Therefore, we are going to get 1275 as a quotient. Now, we will be dividing this entire number 1275 again with 3 in order to get 425 as a quotient. Now this 425, it is not divisible by 3. The reason being, you will get 4 plus 2, 6, 6 plus 5, 11. 11 is not divisible by 3. So therefore, we will try dividing 425 with 5. Because the unit place of 425 is 5, hence it is divisible by 5. So we will try dividing. We are going to get 85 as a quotient. Now again, 85 is neither divisible by 2 nor it is divisible by 3. So therefore, we will try dividing it with 5. We are going to get 17 as a quotient. Finally, 17 is a prime number, so therefore, we will divide 17 with 17 only, and hence we are going to get 1. Now let's write down 3825 as a product of its prime factors. We will be getting 3825 is equals to 3 into 3 into 5 into 5 into 17. Now, since 3 is occurring twice, 5 is also occurring twice, we can write down this in terms of 3 raised to 2 into 5 raised to 2 into 17 raised to 1. So, this is the way we have prime factorized 3825 in the product of its prime factors. Those are 3, 5 and 17. Now, this is the fourth subpart of question number 1. We have to prime factorize 5005. So, we will be dividing first of all 5005 with 5. We are going to get 1001 as a quotient. Now, 1001 is neither divisible by 2 nor 3 nor 5. So, we will try dividing it with 7. And hence, we are going to get the quotient as 143. Now, let's try dividing 143 with 11. We are going to get quotient as 13. And since 13 is a prime factor, so we will be dividing 13 with 13 in order to get 1 as a quotient. So now 5005 can be written as 5005 is equals to 5 into 7 into 11 into 13. Now here every prime factor is occurring once. So we will be writing 5 raised to 1 into 7 raised to 1 into 11 raised to 1 into 13 raised to 1. Now this is the fifth subpart of question number 1. We have to find out the prime factors of 7429. So let's prime factorize it. 7429. We can divide it with 17 and we are going to get the quotient as 437. Now next, the number with which we can divide this 437 is 19. So, we will be getting, on dividing 437 with 19, we will be getting 23 as a quotient. Now again, 23 is a prime number. So, we can divide 23 with 23 in order to get 1 as a quotient. So, now we can write down 7429 equals to 17 into 19 into 23. And since every prime factor in this prime factorization is occurring only once, so we will be writing it as 17 raised to 1 into 19 raised to 1 into 23 raised to 1.